All right. Good morning, folks. It's feel like it's been a while since I've actually recorded one of these, so I do apologize if I'm a little stumbling on my words. Um, all right. So what we're looking at with this particular lesson, and I do apologize for the focusing. That's the one issue I know I have sometimes with this is we're evaluating functions with notations. In other words, normally what you're probably used to is if you're given, I'm going to use something similar like, y equals x plus 1, and then you're told, that if x is equal to 2, then you would substitute or plug in, y equals 2 plus 1, and then you get that y equals 3. Okay, so that when x is equal to 2, y is equal to 3. Okay, that's what you're probably used to. The idea is the same. What changes is how it's written and what it looks like. Okay, so I'm going to show you how to evaluate, which is the same as solve. Okay, for value of x, or if you need to find a value of x, if you're given the f of x value. Okay, that's going to be the new part for you. So what I want you to understand is that function notation. And so instead of writing y equals x, we're going to basically be writing f of x is equal to x. So it looks something like this, where f of x is equal to x. And I know that looks a little weird, but I want you to kind of get the idea of that this is y equals x. This essentially is y equals x, except instead of writing y, we are writing f of x instead. Okay, and it doesn't have to be f. It can be g, h, I, j, what so have you. Actually, I is not a common one at all. But f, g, h are common ones. For future reference, the reason why we do this is because down the road, at some point, you will probably start seeing things like f of t, for example, and that usually is used in terms of time. We're not there yet, but just kind of getting ideas why we're doing this now, because later on, when you start seeing things like f of t, you know that the idea is similar. Instead of calling it x, we call it t for time. Okay. And when I talk about evaluation, essentially what I'm going to be doing is substituting a number value in place of a variable. Okay, that's what I'm going to be doing. So whether I'm given the x or the f of x, that just determines on how I substitute it in and then solve it from that point on. Okay, so at this point, hopefully you've gone through the solving lesson, so that way this is a little bit simpler for you. If not, that's okay. I'm going to run through it anyway. So simple, basic kind of steps for you if you need it. 1, decide which one you're given and which one you have to solve for. Okay, we're going to substitute the value into the appropriate variables, and then we're going to solve for the unknown variable. That's the basic process for what we're about to do here. Okay. At some point, I'll say, okay, go ahead and stop trying on your own, and then I'm going to pause this, and then what will happen is next time if you keep playing, all of a sudden the work's going to pop up for you so you can check your work. So when I say, pause try on your own, that's kind of the clue is you might want to try to do work before you check to see how I did it to compare what you did. Okay. And again, I do apologize for the focus if it does go out of focus at some point. I'm kind of working with some odd technology here right now. All right, so here's what we have. So this is a straightforward, we're going to evaluate the following expression given the functions below. So here's what we're looking at. There's two parts to this. There's wrong color. I want these colors right here. Sorry, I've got a lot of color right now. There is an f of x part, and then there's just an x part. Understand that they are two different things. Okay, this does not mean to do f times 5. That's not what it means. This piece is considered to be one component, one part by itself. Okay. But what it does mean is this. This 5 is telling me what the value of x is going to be. So it's basically telling me that x is equal to 5 at this point. So when I say what is f of 5, what I'm really saying is I know that x is equal to 5. Therefore, what would the y value be for the output? Okay. And so what we do is we take this value of 5 and where my variable is going to be at, which I could have more than one variable. Okay. I'm going to substitute it in for that particular variable so that it looks something like this. 2 parentheses of 4 times 5. Notice I turned this into parentheses instead of leaving it as an x. Minus 9 plus 3. Excuse me. And then we use your order of operations to actually solve. And I'm going to run through this by hand. But again, if you do have a calculator, trusted calculator, it's good to use that as well. The reason why I'm doing this by hand is because for future reference, again, if you don't have a calculator available, this is kind of what you want to be able to do. So this becomes 2 times 20 minus 9 plus 3. 2 times 11 plus 3. 22 plus 3. Therefore, the answer is 25. So what we have is whenever x is 5, then the value of f of x, or the value of y, is 25. And the answers are typically written to the effect of f of 5 is equal to 25. Now, I know it looks a little weird, and you're saying, well, isn't this y? Technically, yes, it's similar to saying y is equal to 25, except that it's written as a function notation. Okay, that's what it looks like. My wife just told me it's raining. Woohoo. Okay, so I'm gonna set this one up first, and then I'll give you a chance to work it out. So I'll pause it, and then work it out on your own, and then we'll see what happens. Okay, so again, this means that my x value is -7. So everywhere I have a variable of x, I'm going to drop in and substitute in a -7 instead. So it looks something like this. And again, if you have a calculator, this is maybe a good spot to have a calculator and use it if you need it. So I'm going to pause it right here. When I come back, you'll have the whole thing worked out for you. So try it on your own, see what happens. All right, how'd you do? So everything I worked out step by step for you again. If you have a calculator, I will tell you this. If you're not sure about this power of 4, this exponent of 4, okay, this is a little caret button right here. So if I want to plug it in, -7 to 4, okay, you get 24/1. Now, I want to explain one thing to you real quick. Make sure you use parentheses when we do this, because if I don't, what happens is you get a completely different answer. And yes, same values of the number, it's a completely different number. One's a positive, one's a negative, and that makes a huge difference in your answers. So make sure anytime you evaluate, we are using parentheses for this. Okay. All right. Here's another one. And again, I don't want you to flip out because you see fraction bar, but that is a fraction bar. Work the top and work the bottom, and at the very end, you'll divide it. I'm not going to set it up this time. I'm going to let you set it up in yourself. But again, I'm going to pause it here. I'm going to let you try to do it yourself, and then we'll come back and see how you did. Okay, there you go. How'd you do? So a couple things again. When I worked the mine by hand, I worked the top by itself, and what I'm gonna do is I'm gonna kind of draw my marks here so you know which part is which. Work the top separately, work the bottom separately. Then once I finished the bottom separately here, I went ahead and divided these two and got this. Now, my calculator is already set for fractions. Here's what I'm gonna kind of tell you about this. If you don't have fractions, this is what happens. You get an irrational decimal number, okay? If you had to check your work, and you use a rounded decimal, your answer may be off a little bit. Okay. What I'm going to highly recommend is leave your answers in fractions as much as possible, unless you have a nice clean decimal like 0.125. Okay. Now, if you do get decimals, okay, for example, there is a way to convert it to a fraction by going math. Number one says fraction. And if I hit enter, it converts it into a fraction for me. Okay, so it's a nice little trick to know if you're not sure. So there you have it. So now I'm going to flip. So this is if we're given, if we know the value of x and we have to find the value of x. That's what these are. Okay. So what happens if, go to another page, you don't know the value of x and you have to find it. Come on, let's focus. There you go. So let me let this focus real quick. It's being kind of weird right now. That's better. Okay. So this is okay, so here's what happens now. Here's your function or equation or expression, depending on what we're working with. Okay. In this case, it's a function. This time it's telling you that f of x is equal to 20. Okay. What it's saying is the entire, remember how I told you earlier that this is considered to be one part or one component? That means that the entire part is the same value as 20. So what we'll do is we will replace this part with 20 instead in order to determine the value of x. Okay. Once you have it set up, now we're actually going to solve for x. We'll use inverse operations again. And that basically means I'm going to start with my subtraction value. I'm going to add it to both sides to undo it. This is 3 times x. And again, to undo 3 times x, I'm going to divide out by 3. And if I do 26 over 3, that's going to give me a pretty interesting decimal. So I'm going to leave it as this. I believe you get 8.66666666 if I remember correctly. Yep, just checked it. So I'm going to leave it as a fraction. So basically what it's telling me is the value of x, when the value of x is 26 over 3, then the output or the value of y, or in this case f of x, is going to be 20. So f of 26 over 3 is equal to 20. All right. Same idea. Come on, focus. All right. So again, same idea. G of x, we're going to replace g of x with the value of 5. So wherever my g of x is at, which is right here, I'm going to replace that with the value of 5. Now, I will set it up for you, and then I'll pause it so you can try it. Right here, when you get to this 5, you will have to do what's called a fifth root. Now, if you don't remember where a fifth root is at, that's okay. If you go to math, right here, number 5, allows you, I just realized something. Hold on. Let me fix one thing real quick. Math 5 allows you, hold on, it's the way it's set up, to put a fifth root into the calculator. Okay, just like that. So let me set it up. I'll pause it, let you try it. Hopefully my camera focuses like it's supposed to. And we'll see how you do. Okay, how'd you do? So I'm going to walk through it for you. So again, first thing is, I want to get rid of this addition subtraction part. So I plus or add 15 on both sides to balance it out and get rid of it. Then again, because this is multiplied, I divide by -4 to balance it out and get rid of this side. So that way all I have left over is x to the 5th power is equal to -5. Now, in order to do a power, okay, so kind of review. In order to undo an x squared, you have to take the square root. So if you had 4 is equal to x squared, you would square root both sides to get the answer. Well, in this case, we take what we call the 5th root of both sides. And again, it is an irrational decimal. So, but in this case, decimal is actually okay. This is actually going to be more common in this case than it is to leave it as the 5th root of -5. If you left it like this, I wouldn't necessarily be upset, but you're probably not gonna see it this way at this level. It's gonna probably be more the fact that you have a decimal, which is okay. Okay, last one. Let me switch pencils here because this one's getting a little dull. Same idea. I'm not going to set it up for you this time. I'm gonna let you do it, see how you do, and again, just work through the process. All right. So again, now this one's a little different because it has this fraction piece of this 4. The fastest way to get rid of these denominators is just to essentially cross multiply back to the original number. So I just multiply 4 times 10 to get 40 first before I start balancing out my equation. Subtract 1 to both sides, get 39. Again, because this is 2 times x, divide by 2. And in this case, if you left it as 39 over 2, that would not be terrible. If you go ahead and go 19.5, that would also be correct because this is a nice rational decimal here. We don't have to worry about it repeating itself or just going on forever. So, all right. Now, one instance that you would see, this is in a proof. Okay, so the question becomes, are these two functions, f of x and g of x, equivalent for the following values of x? Okay, so first of all, the word equivalent means, are they equal? Okay, so like for example, when x is equal to 1, are they the same? And here's how you know. I have to evaluate both functions with the value. And if the output is the same for both, then they are. So for f of x, I would take 2 times 1 plus 30 and see if it's the same thing as 3 times 1 squared minus 3. Well, 2 times 1 is 2 plus 30 is 32. 3 times 1, well, 1 squared is 1. 3 times 1 is 3. 3 minus 3 is 0. So right off the bat, they're not the same output value. They're not equal to each other. So for this, they're not equal at x equals 1. Okay. Let me write that here. So not equal at x equals 1. Okay. That's what you're doing on these. That's what you're proving. Okay. This is another one. Same idea. I'm going to pause it, let you, oh, come on, refocus now. I'm going to have to upgrade my cameras at some point. Pause it, let you try it, and see how it comes out. All right. Again, I did the same thing. I substituted in -3 to the first equation, -3 to the second equation. Worked it out by hand. -6 plus 30 is 24 on one side. This -3 squared becomes 9. So that you know, anytime you square a negative in parentheses, it becomes positive. 27 minus 3 is 24. So at x equals -3, they are equivalent. And so you should know what that means. It means that if I had two curves or lines, this is the point right here that they would actually cross each other, like intersect each other. Okay, I'm not going to show you that right now with this one, but that's actually what it means. Okay, here's another one. Yes, I know there's fractions. Again, it's something that you want to kind of get used to. But again, if you have a calculator, use it. I'm going to pause it. Let you see how it goes. Okay, you probably picked up your calculator for this one, and that's okay if you did. I did mine by hand again, just to kind of show you some tricks. I really, really want you to eventually not have to worry about calculator, but if not, it's there for you. Okay. So again, I substituted in 11 over 3. So whenever you multiply, this is 2 over 1. So I essentially just did 2 times 11 to get 22 over 3. And then to add 30, here's kind of a tricked way of doing it. I did 3 times 30 first, which was 90. And then I added 90 plus 22. And then that's where the 112 comes from. And notice my denominator did not change. Okay. That's a way of doing it if you don't have a calculator. 3. So when I square my fraction, I have to square the top and the bottom number. So this is 121 over 9. And again, a little trick is when you multiply, you can reduce out. So with this, if I make this go away, become 1, and this becomes 3, then I have 121 over 3 instead. And then I do the same thing. 3 times 3 is 9. 121 minus 9 is 12, or 112, sorry. Again, my denominator does not change. So in this case, they are equivalent at that number. But again, if you have a calculator and it's available, please use it. Okay. Okay. So evaluating from graphs. This is actually a little bit simpler. So you want to make sure and identify what variable you are looking for. So in other words, what this is asking for is, first of all, you see how this is the F and this is the G? This is F, which means that anytime you see the letter F, you're going to be using this graph to do it. If you see the letter G, you're going to be using this graph to do it. Okay. I won't be able to show both at the same time, I don't think. I'm going to try. I can certainly try. Let me straighten my paper out here. But here's the idea behind it so that you know. Okay. Oh, my camera's all jacked up now. There it goes. Okay. So what this is saying is when x is -2, okay, what is y? Or what is the y value? So you can't see this on my paper, and I do apologize for that, but this is actually by 2's on my paper. So like this is -2 right here. I think, hold on. I should probably go back and look to see exactly what I have. That should be right. Yeah. Okay. So what it is you go on the x-axis, which is the x-axis. This is the f of x-axis or the y-axis, okay? And you figure out, okay, so when x is -2, what is the y value? So what you do is you go down till you hit your graph. And in this case, this is probably not a good example to start with. I kind of just realized I made a mistake when I did it, but not a big deal. It works. Since my line does not actually hit this graph in any form or fashion, there is no y value. There is no output. So this is actually eventually what we would consider to be no solution, but we'll just call it not possible for right now. Okay. That's kind of weird. But I'll do another one. So like over here, hopefully you can see it. This one I believe says, yeah, f of -10. So when x is -10, so I come over here, well, here's -10. Well, it hits my graph here, and it hits my graph here. So there's a value here, and there's a value here. Now, it's not pretty. It's not exact. And again, I do apologize that my paper did not print like I wanted it to. But this one actually has 2 possibilities. And I'm going to approximate this for you. But it looks like it's maybe approximately negative, I don't know, 2.2 on the first one right here. And on this one, it looks like it's maybe negative 9.7. Okay. But that's what it's asking for. These are your y or your f of x values. Okay. Then on letter E, let me show you letter E without having to move everything. You see how it says f of x is equal to 0. What it's basically saying is, now if you know that y value is 0, what is x? Okay. Well, since I know my y value is 0, my y value is actually the x-axis right here. And I know whenever y is 0, it's this particular point right there, which is negative 22. So my x value at that point is negative 22. Okay. So now I'm going to go to my G graph and do the same thing. Or you can go to your G graph and do the same thing, and then I'll kind of go through. I'll pause it and go through it. Okay. So for my first G value, when x is 3, or G of x is G of 3, I got and again, I approximated to be around negative 0.3-ish. And again, it plus or minus, it's not. For G of negative 4, I got it's negative 1. So here's negative 4, here's negative 1. And then if you have the y value instead of negative 1, which is going to be along this line right here, you actually have two values. Either x is negative 4, well, because we just did that one, or it could also be that x is 2. Okay. So that's looking at values from graphs. This is videos being a little bit longer than I anticipated. Okay. From a table, this one's actually a little bit easier. If you have a table given, then you look at identify what's what. Again, this is an x value. This is an x value, or in this case, an a value. And the reason why I know it's an a value is because if I read the prompt, it says h of a. So this would be considered a. This would be considered h of a. Okay. This is an a value. This is what we consider to be an h of a value, so it's almost like a y value. Same thing here. And it tells me which one to look at. Okay, so like for example here, h of 0.5. 0.5 means I'm going to look under this column and figure out what is it equivalent to. Well, 0.5 I know is 6 months. That's half a year. My height, or the height in this case, would be equal to 26. So that's considered 26 inches. Okay. H of 2, I know is 2 years. The height, 2 years equivalent, is 36 inches. H of 8 is 8 years. Height is 51 inches. Here, it tells me that my y, or my h of a, is 39, which is the second column. So it wants to know what is the number of years in this case. So at 39 inches, then my years, or my age at that point, is 3 years. And then same thing with 47 inches. It looks like my height's going to be roughly 6 years. Okay, and that's evaluating with function notation. All right, the only thing left is SAT explanation. So if at this point you just want to get into the job or get into the work, you can, but I'm going to kind of explain the SAT at this point a little bit. So this is usually how it could be represented on the SAT. my resources include anything and no affiliation with them, but Princeton Review, Barron's, USAT books. So I'm not making this up. I'm kind of, well, I am creating these on my own. I can't actually use the exact questions, but I am formatting them based on that. So it's an evaluation question. Okay, and the question is, if you have g of x and you have f of x, what is f of 2? Okay, so notice one thing. There's a g right in the middle here. Okay, so what we do is we take this 2 first, and we're going to substitute in the x with the 2. Because now, if you look how this is g of 2, I can take this and figure out, well, if this is g of 2 is equal to 3 times 2 minus 5, I can figure out what value is going to go here before I can actually finish working this part out. So that would be 6 minus 5, which would be 1. So g of 2 is 1. So I come back over here, replace my g of 2 with 1. And so I get the fact that f of 2 is equal to 9. Okay. I know it's a little confusing. This is actually multiple evaluations. So, but that's kind of how it's, that's one representation of it. Okay. But it's one that fits with what we're doing right now. It just means that you have to be able to plug it into multiple spots to figure out what you're looking for, or what it's asking for. All right. You have a good deal. And like I said, this probably went a lot longer than I wanted. See ya.